Okay, my suggestion is write a few terms down. So let's put this over here, n equals 1 to infinity, and this is 3 to the n, and then I get 2 to the n plus n squared. And let's write a few terms down. You know, one thing at a time. Let's do the top first. So it's 3 plus 3 squared plus 3 cubed. I think you get the idea. It goes on forever. What goes on bottom? It's 2 to the 1 plus 1. Right, because, you know, 1 squared is 1. Let me put 1 squared down. Then what do you get? You get 2 squared plus 2 squared. Then what do you get next? You get 2 cubed plus 3 squared. I know I'm jamming it in there. I certainly know it's a positive term series. I know that much. I want to kind of look at it term-wise, though. I'm wondering if it's actually decreasing. And looking at it, well, the first term is going to be 1. The next term is going to be 9. And then what do you get there? 2 squared plus 2 squared, that's 4 plus 4 is 8. So that actually jumped up. So this one up. All right, let's look at the next term, by the way. What do you get there? 27. And the next term would be what? You know, 2 cubed, which is 8. 8 plus 9 is going to be 17. All right? And I'm kind of looking at that, and I'm starting to realize that, you know, just looking at it, let me write this down for you. The relationship between these two terms, you know, is it going up or down over here? So it's, you know, 9 times 17 and 27 times 8. Now, what do I know about that? 9 times 17 is certainly going to be less than 27 times 8, all right? You know, 9 times 10 is 90 and 63, 153, and 8 times 20, 160, and you get the idea, it's bigger. So I'm looking at that, it looks like it's going up, all right? So a couple of things you could do, and I want to point out, you know, someone says, well, one day you do one thing, another day you do another. I'm kind of looking at it, and it sure does look like it's increasing to me. And this might be something you want to try to do. I'm going to use the test for divergence over here. So I'm going to write down limit as n goes to infinity of 3n, and this is going to be 2n plus n squared, all right? I'm kind of looking at it. It looks like it might be a tough limit to do, but you know what? Maybe I can do it. And if you did this over here, and limit n goes to infinity, and what I notice about, yeah, maybe I don't need to do write another limit down. What am I noticing over here? That this guy over here grows much faster than this guy over here. Again, you may be disturbed by this thing over here, but these exponentials are growing much faster than the n squared is, much faster. So I'm going to say this goes off to infinity, all right? Now I want to go just back to, in calculus, what you did, and not that you have to go there, but let me just go through that with you. Let me get my eraser out, and you can start to erase things. You may also want to look at, you know, limit that you're more familiar with over here, just to convince yourself of this. And this is going to be this one over here. X goes to infinity. And what do you get over there? 3 to the x, and that would be 2 to the x plus x squared. And I would say over here, I hope you realize top goes to infinity, bottom goes to infinity. It's L'Hopital's rule. I'll put a little h over here. I want to remind you, though, that y equals a to the x. You're going to do that guy's derivative. We'll talk about that in a second. Natural log of both sides. That'll be x ln a, 1 over y dy dx, and that would be ln a. So dy dx is going to be equal to, well, let's see, it's going to be y, which is a to the x, times the natural log of a. So let's write that down. It's going to be limit. I'm going to do the derivative of the top, and that's going to be the natural log of 3 times, let's see, 3 to the x. What goes on bottom? Well, the natural log of 2, and then it's going to be 2 to the x. And then the derivative of x squared, that's easy. That's just going to be 2x, all right? L'Hopital's rule again. The top goes to infinity, the bottom goes to infinity. So what do you get over here? Let's write this down. Limit x goes to infinity. And then what are you going to get? Well, you're going to get ln 3. Let's see, the derivative of the 3 to the x is ln 3, 3 to the x. What do you get on bottom? ln 2, 2 to the x, plus 2. Well, again, L'Hopital's rule again, the top's going to infinity, the bottom's going to infinity. What do you get over here? Let's write this down. Limit x goes to infinity. I think you get any idea what's happening over here. ln3, 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 3 to the x, ln2, 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 2 to the x. Now what about this over here? Looking at it, certainly the growth is enormous. It's infinity, as we said, going off to infinity. You don't have to do that though. So if someone says, you know, you did something different in your notes. Let's go through that. You know, the one thing I did was I kind of rewrote it. I'm not sure why I did that, by the way, but I just rewrote it 1 plus. It really doesn't change the problem at all, right? Now, the first term would be 1, and why is that? If you put a 1 in the first term, what do you get? You get 3. On bottom, you get 2 plus 1. 3 over 3 is 1. I'm not sure why I did that, but I did that over there. The next thing I did, I want to point out, I did a comparison theorem, and I made a comparison with the harmonic series. And what I said that 3 to the n as a term, and now I know I did the n one, that this is true, that this guy here is going to be greater, all right? And that's why, we'll go through it, by the way. What do you get over here? Let me write this down. It's n. By the way, n is a number that I'm going to say is positive at this point, right? What does it mean greater than 0? We'll talk about the other restrictions later. 3 to the n. What goes over here? Well, 2 to the n plus n squared, all right? And kind of looking at it, you start to realize that, you know, one side grows faster than the other. And what side's going to be growing faster than the other? This side's growing faster than the other. Now, someone could say, I wonder where that occurs. Let's talk about that. Let's talk about, does it happen at 1, right? When's the takeoff going to occur? What do you get here? You get 1 times 3. What do you get over there? Well, you would get 2 plus 1. It's not true at 1. Let's try n equals 2, all right? So what do you get over there? You would get 2 times 3 squared, which would be 9. So at some point it's going to take off, by the way. What do you get over there? 2 squared is 4. And what do you get? Again, 2 squared is 4 again. It takes off here. So that's why I did this over here. I started at 2. So this is true for n greater than 1 or n equal to 2 and above. All right? So this is over here a comparison. Now, by the way, the comparison is not a bad idea to do, but again, you could have also done the test for divergence, what I did over here, and just looking at it, those terms are going to its infinity, by the way. Thank you.